So today we are going to discuss about the 2022 GATE questions, and for that we are approaching to solve the questions with short tricks and the minimum time that will consume per question. So we will start with this question. So in this question, what you have to first consider is, in this question what you have to consider is that you have a benzene on which SiMe3 group is attached, and along with SiMe3 there is OTF group, which is a very good leaving group. So what you have to consider here is, along with that we have a two reactants here. If I'm saying that we have a two reactants here and we have a CSF, you know what the CSF is? CSF is another reagent in which we have a fluoride ligand, and if we have a fluoride ligand, then that particular fluoride ligand act as a nucleophile, because that particular nucleophile attacks on some electrophilic centers, so that will act as a nucleophile, and MECN is a solvent. So we have a two reactants and one reagent. So how we are going to solve this particular question? So what you have to do is just consider this question. So in this particular question, what the reagents that we have? So what the reagent that we have is, I have said that we have a benzene, and on the benzene, if I will say like we have a SiMe3 group, we have SiMe3 group and OTF group. So in that, in the presence of CSF, and the CSF is present in 2.5 equivalents. So what happens? 2.5 equivalent, that is CS positive and F negative. So it will attack on this particular carbon, and this will go on this way. There is a formation of benzyne. So in this particular reaction, the benzyne is the intermediate. So what you have to see here is that this particular CSF attack on this and this, there is a formation of benzyne. So in this reaction we have the formation of benzyne. I have explained like how the benzyne is forming, but we have 2.5 equivalents of CSF. So if we have a cesium fluoride, that is 2.5 equivalent, one equivalent utilized in the formation of benzyne and another utilized in the abstraction of acidic hydrogen, and there is the formation of this particular product. So we have OMA on one side and we have MA on another side. So this particular CSF attacks on this particular hydrogen, because that hydrogen is very acidic in nature, and if the hydrogen is very acidic in nature, so you have to carefully see that if the hydrogen is acidic, so that's why the nucleophile abstracts the most acidic hydrogen. So F minus will attack on this particular hydrogen, and if the F minus is attacking on this particular hydrogen, there is a formation of a nucleophile. This nucleophile attacks on benzene, and on benzene we acquire a negative charge. So how you are going to neutralize a negative charge? While if you go through this particular reaction, you will come to see that this is the substrate that we are getting. So this is the substrate that we are getting, that is this. When you attack that particular acidic when you attack this negative charge on this particular benzene, then what you are getting? You are getting this particular product. So when you are attacking this, you are getting this particular product. In the exam, you have to draw the products, so you have to be that much comfortable in drawing the structures, drafting the mechanisms and all. So we have this particular thing, and minus and CSM plus. So when benzene attacked by the acidic hydrogen, after the abstraction of acidic hydrogen, then we are getting this particular product, which is a cesium salt. And this is a cesium salt, and this is a very important intermediate, or you can say the very important as a part of the reaction. It's very important. And after that, what you have to do is, this particular negative charge attacks on this particular position. Why I'm saying so? Because the negative charge attacks on the electrophilic center, and if the negative charge attacks on the electrophilic center, we are going to get this particular intermediate, in which we have a C connected with C double bond to OMe. This is connected with this CMe, and we have a O negative here, and this O negative, and this particular negative charge attacks on this C like this. So we are getting this particular product. This will come back in this way, and this way it leads to the formation of the product, that is this, in which we have a benzene. On the benzene we have C double bond O Me, and here we have C double bond O CH2Me. So we have these types of the products. So this is the overall mechanism that you have to solve in the exam in a very short time, like in 1 to 2 minutes you have to solve. So you have to see if you have a nucleophile. You have a nucleophile. This nucleophile will abstract the acidic hydrogen, attacks on the silicon group and forms a negative charge. Benzene is formed as an intermediate and the nucleophile attacks on this, and you are getting your product, and this is your answer. This will be your answer because you have to draft the whole reaction basically. Now come to next question. This question is very easy because if you know that this particular product we have, the like which particular product is forming. So if you know, like if this particular A reaction is going to happen, that particular A reaction is stereospecific. If you know that this particular reaction is stereospecific, then it becomes very easy for you to solve the question. So we have alkyne. We have this alkyne in the dipole form. You have to see this. So you have alkyne in the dipole form. If this and this is going to react, then you are going to get a product like this. When you have nitrogen, oxygen, this is a cis addition. So basically you will learn this in the name reaction very properly. So it's a very important part of the name reaction. And if you have another CH3 on this side, because it's a cis addition, I have already told you that this particular reaction is stereospecific and happens in the cis way. And if this particular reaction happening in the cis way, then you have to say this is Me, this is Me, and this is Me. So this is the first reaction when we have a reagent A. When we have a reagent A and it's reacting with this particular reagent, then this is stereospecific reaction and the reaction happens in the cis way. And we have H2 in the presence of red and nickel. And we have H2 in the presence of red and nickel. So what you have to do here is, the reaction will happen and there is a cleavage, and there is a cleavage in such a way that cleavage done from this particular bond. And when H2 in the presence of red and nickel is going to attach, you have to just remember the very short and quick reactions, because there is a formation of imine. And in the organic chemistry, if the imine is forming, so let's consider this example. When you are getting amine, so when you are getting amine in the organic chemistry, then what you have to consider is, you have to consider this particular reaction, which is a very short reaction in the presence of H plus, in the presence of H2O. In this particular thing you are getting amine. So how you are forming this? So there is double bond N, there is positive H charge. So we have H2 again. We have H2 in the solvent. Then what we are going to do that? There is a formation of NH3 plus. There is the OH2 plus. Why I have written that? Because this particular thing attacks on this and the pi bond shifts on the nitrogen. So in this we are going to remove the ammonia, and you are getting a C double bond O group. So this is the simpler way, that if we have an amine, then what's the final product is? Our final product is carbonyl group. So our final product is carbonyl group. So what you have to consider here is, if our final product is the carbonyl group, then you are going to directly draw this structure, that in the reaction we are getting this. So then you have to be very specific. Then in the reaction you are getting the carbonyl. So as per that carbonyl, so it means that the C and D products cannot be possible, because one carbonyl is also there. This and this is not possible. So there is answer from this. I have told you that the addition of MEOH in particular reaction is stereospecific. It means that there is a syn reaction. It means that it's a syn reaction. And if it's a syn reaction, so just suppose if I'm talking about syn reaction, if it's a syn reaction, then Me and OH adds on the same directions. Me and OH attacks on the same direction. So our answer is A, because this Me and this OH should have same stereo. This M and this OH should have same stereo.